Earlier we talked about congruence. In this section we're going to be talking about congruent figures. In this case we've got some rectangles and some triangles right here. Each figure is congruent if they are exactly the same size and exactly the same shape as each other. We can analyze that by taking a look at the individual sides. So you'll notice that these two triangles both have 4 sides. If they are congruent, each side should have a corresponding side that is congruent in the other triangle. So we've got this one and this one. These two are congruent to each other. This one and this one are congruent to each other. This one and this side are congruent to each other. And our 4th side are congruent to each other as well. The second piece is every angle should have a corresponding congruent angle. Now on these you can just kind of eyeball it and see, but if we measured each of these we would see that we'd have 90-degree angles for each of the corners, so all of the angles have a corresponding angle that's exactly the same measure in the other side. Let's take a look at our triangles right here. These two triangles are clearly not the same shape. We've got this wide angle right here that does not have a matching angle over here. Also, we could take a look, this short side right here does not have a matching short side over on the other triangle. So these are not congruent to each other. So as we go through, we're taking a look, do they have corresponding sides and angles that are congruent, or do they not? And that will tell us if they're congruent or not. Now there's a couple of vocabulary words that we can use when we're working with transformations to tell if something is congruent. The first one is congruence transformation, and the second one is rigid motion. Now rigid, the word rigid, is that something is very stiff and unbendable. We can't move it, we can't bend it. So you take this board for example, I can't move it, I can't bend it, I can't twist it or shrink it or crush it. That is an example of something that is rigid. Now a rigid motion is something that keeps everything the same. So just like I can't bend or crush or move this piece of wood right here, a rigid motion won't bend or stretch or crush or change the shape in any way. There's a few different rigid motions that we can talk about. If I do a rotation, that rotation did not change the shape of this board at all. It is congruent to what it was before, so this rigid motion kept it exactly the same shape. Same with translations, sliding it up, down, left, right, diagonal. Translations keep things rigid. Nothing changed about the shape of this. And then reflections as well. It's hard to do with this. Reflection, turn it backwards the other way. A reflection will also keep it rigid. Now, under those 3 different motions or transformations, this piece of wood is congruent to what it started with. And so these two concepts are exactly the same idea. A rigid motion keeps the same shape. Those 3 motions are rotations, translations, and reflections, which we studied in past sections. If you do any one of these 3 things, it is rigid. It keeps the shape the same. It might move it, it will move its position or flip it around, but the shape does not change. Consequently, those 2 shapes are going to be congruent. So congruence transformations also are rotations, translations, and reflections. If you do any of these 3 things to a shape, the resulting image is congruent to the pre-image. So these 2 terms right here are interchangeable with each other. You could call it a rigid motion or you could call it a congruence transformation, but this is how we tell sometimes if things are congruent to each other. Now let's take a look at this diagram here. Our job is to decide which shapes are congruent to each other, and we'll talk a little bit about how one of them turned into the other. So if we look at this shape and this shape right here, the 2 triangles, we can see that they have corresponding congruent sides. This side is congruent to that side. This side is congruent to that side. And this third side is congruent to this third side over here. Each of the angles is also congruent to a corresponding angle in the other figure. So we have two congruent figures. Now, how do we turn one into the other? This is a rotation that takes it from there to there. It's a 180-degree rotation. Or, there are other ways that we could do this. If we took this shape and reflected it across the y-axis, we end up with a triangle that looks like that. And then if we reflect that across the x-axis, that will turn us into this triangle over there. So there's a couple of ways to turn one into the other. These two triangles, triangle TUV and MNP, are congruent. We get those by rotating, and we can confirm the corresponding congruent sides here, here. This is congruent to that one, and this is congruent to that side right there. So these two are congruent through corresponding congruent sides. Let's take a look at now the two rectangles. These are congruent to each other. We can see this side and that side are congruent. This side and that side are congruent. This side and that side are congruent. And this side, fourth one, is congruent to that. So we have two congruent rectangles. How did we get one to the other? Now this one could be a translation where we translate it over to here. That would be a translation of 1, 2, 3, 4, 5, 6, 7 units to the left, and then get this rectangle right there, and then we translate it 1, 2, 3, 4 units up to get that triangle. So that could be one, or we could translate it up and to the left. That would work. Or if we wanted to do a reflection across the y-axis, that'll turn it to there, and then a reflection across the x-axis would put it up here, and then we could translate that down. So there's quite a few different ways to think of different congruence transformations. It doesn't matter which one you pick, as long as your transformation or set of transformations takes one shape onto the other. Thank you.